Hello, everybody. My name is Mirko Novakovic. I am co-founder and CEO of Dash Zero, and welcome to Code Red. Code, because we are talking about code, and red stands for requests, errors, and duration, the core metrics of observability. On this podcast, you will hear from leaders around our industry about what they are building, what's next in observability, and what you can do today to avoid your next outage. Today, my guest is Anish Agarwal. Anish is the co-founder and CEO of Traversal, an AI SRE agent for enterprise businesses. He's also an assistant professor at Columbia University, researching causal machine learning and reinforcement learning. Anish and his team raised $48 million in their seed and Series A funding round this year. This is kind of part of the growing traction in this space, AI SRE. Excited to have you here, Anish, and welcome to Code Red.
Thank you so much for having me. It's a pleasure. We met probably 15, 18 months ago, and I felt like I've lived a few lifetimes since then. I'm sure you feel the same.
I can tell you that in the startup life, a year always feels like a decade at some point. So before we dive into this, I always start with one question. Which was your biggest Code Red moment in your career?
It's a good time to be asking this question because tomorrow there's a big deadline for a conference called ICLR, so International Conference on Learning Representation. So it's like the big conference for deep learning that people have. So it made me think, as I was thinking about this question, that a few years ago I was trying to submit a paper to NeurIPS, which is another big machine learning conference. And the results looked really good, really promising. And then I think maybe a day before we were about to submit, we were looking through the results and like our code, and there was like this really stupid mistake that we made, and none of the results made any sense. So that was a big Code Red because we tried to salvage that paper over the next 24 hours, trying to fix that bug. Yeah, it was like a random seed that we didn't set correctly. So we kept changing the seed and kept moving the results in a weird way. So that's probably the biggest Code Red.
And before we start into this whole area of AI SREs, I was looking at your resume, and I mean, it's pretty amazing, right? A PhD at MIT, you are a professor at Columbia University in this field of machine learning. So why did you pick this kind of topic? I'm super excited because you could have picked every topic essentially, but you picked observability or this SRE space. So why?
Yeah, it's a good question. Like 24 months ago, about exactly 24 months ago, September 2023 is when we kind of started this journey. And at that point, I never heard the word observability. I never heard the word SRE. So it feels like crazy almost. I think for me, my motivation to create the company came from research. I love AI, I love machine learning research, and I always wanted to be at the edge of it. And I think just in the last couple of years, with everything happening with OpenAI and Anthropic, it just felt that so much of the frontier is now happening in companies. And so I wanted to be part of that. And I felt being at a startup, taking on a very technical problem with research, being part of the culture was my expression of it. So that was my motivation to create the company, along with my co-founders who I met at MIT, and we all had the same motivation for creating it. When we started the company, we had no idea of the exact problem we were going to take on, but we had a pretty clear taste in the problem. So our research was in a field called causal machine learning. So the idea being that, as you know very well, Mirko, like correlation isn't causation.
Mm-hmm.
And so how do you get these AI systems to pick up cause and effect relationships from data? I love the problem. It's like a very like philosophical problem almost, like what does cause even mean? And, viewing that through the lens of machine learning and statistics, I just really enjoyed and I like thinking about. And so we're looking for problems at the intersection of causal machine learning, reinforcement learning, which is about how do you search effectively, and how it connected with agentic systems. And this is like, 18, 24 months ago, before AI agents were cool, but it was very obvious to us that this is something that was going to become very important. And so we were looking at where was the intersection of these two things. It was actually our fourth co-founder. He was from Citadel Securities. And as you can imagine, it's a company that cares a lot about uptime, being highly reliable, and so having very disciplined incident response process, something that, is important to them. And so he's the one that kind of was telling us of this problem of incidents and observability. And then when we spent some time on it, we're like, okay, this is a great problem. It's almost like we were built for this problem. We just didn't know it existed. And if you think about it, it's what happens, right? You have some spike that occurs that you care about, like latency has shot up or whatever. And the problem is there's 1,000 other spikes happening at the same time, right? Because when something goes wrong, it spreads like an epidemic through your entire software system. And so the problem is like, how do you figure out, as a given spike, a symptom of the issue, a spurious correlation, or truly the root cause? So it's about like finding this needle in a haystack, right, with many fake needles everywhere. And that's exactly what our research was about. And that's exactly what these LLMs are good at understanding, right? Because logs and metrics and traces, that's what the haystack is composed of. And so it felt like where the generational wave of technology was going, what we would be very good at, all fit really nicely. And, observability is a big market. It's a growing market. It's an evergreen market. It's always, everything has to be monitored always. And so that was our motivation, I guess, to get into the problem. It was one of our co-founders told us the problem. It felt like founder market fit was strong.
No, that makes total sense. By the way, I learned of causal AI when I talked to two PhDs from ETH Zurich.
Yeah, they have a very good strong program there.
Yeah, and they were solving the problem of production of chocolate.
Yeah.
So there are many things in the chocolate production. If you change something, then the output is either broken or not, right? And they had this whole management of the process using causal AI. And at that point of time, it was really like I kind of understood, oh, this is something that you could apply on
Yeah.
this topic in observability, right? Because there are also many different things, right? That
Yeah.
if you change them, they can have an impact on any other thing in the system, right? And so having some understanding of causality is super important, right?
Yeah, my co-founder actually spent a lot of time thinking about gene networks. So where you have a network in the Broad Institute at MIT, where you have all of these genes that are connected in a network, and you're trying to figure out what collection of genes makes your eyes blue or brown or whatever. But the thing is, when one gene pings, changes, then it affects the entire network. And so it's the same problem where you have this like network of things, one change affects everything. And so, yeah, it's a pretty interesting universal kind of way of looking at a lot of problems, which is why I really enjoy studying it.
Absolutely. And now there is this new category, I think, called AI SREs, right? How would you explain that to a user? Why should you buy it? What is it? And how do you see that space evolving?
Yeah, I think in some ways AI SRE is the category has been called this. That's what we're going with, but it's doing one part. I'd say, at least right now, if I think about the category, it's doing one part of what an SRE does, right? So if I think about an SRE's function, it's both it's about the design of systems that are resilient, right? That will be resilient over time, and how do you actually make the right decisions for your infrastructure such that it scales over time. And the second part of it is the maintenance of these systems, which is once you've built something, you now have to make sure that if something breaks, you figure out how to troubleshoot it and bring it back to the intended service. So I'd say the category is being called AI SRE, but really what everyone's focused on is the problem of maintaining the system, not designing the system, at least so far. And that's where we are as well. And within that space, if you think about what happens when people are thinking about on call, right? It's really, one is you have a lot of alerts, which is, you'll have this constant stream of alerts because people will configure the alerts in some way, and you'll have thousands of these alerts that are happening. And it's someone's job to look through all of them and see, is any of these alerts important? Is there a cluster of alerts that, mean something, and triaging those alerts. Then there's the second part of it, which is you've decided something has become an incident. It's a big issue. You're bleeding. And you now need to, bring 30, 40 engineers into a war room, and everyone's, every second is ticking. You're trying to figure out what happened. And so I'd say, if I think about the AI SRE category, it's really about two things right now. One is about alert triaging, and the other one is about like complex instance response, and also remediation of both of these things. So I'd say that's the place it is. There's obviously many, many other functions that SREs do, like instrumentation, design of systems, which I think is not what quotes unquote AI SRE as a category right now is. And that part of it though is really painful, right? Because you have engineers, both SREs and just on-call engineers, who have to be staring at dashboards, trying to keep all of this context in their head over the thousands of different signals. And when something happens, dumps to dive through all these systems to get to the answer. And it's very hard for any one engineer, because it's very hard to look at all of these signals at any one time, because you just don't have enough context. And so the AI SRE category is about, or solutions are about, can you essentially read all these different disparate signals and start diagnosing incidents far, far quicker with far less on-call engineers than what we have to do now. So I'd say that's the category.
It makes total sense. I mean, I remember the category AI ops. It's a few years
Yeah.
ago, right, that evolved. Companies like Mooksoft or Big Panda were
Mm-hmm.
big, where they basically attacked the first problem that you described, right? Having a lot of incidents or alerts coming in and then figuring out, aggregating them and figuring out
That's
what
right.
was the initial alert. That category never really took off in my point of view, right? I don't even know
That's
if
right.
that term exists anymore. AI ops. I don't know. I haven't heard it, but Gartner was really big on it at a
Mm-hmm.
time. And I totally see that what you described, the second step is really important, right? Supporting the engineer in finding the needle in the haystack, right? Doing the root cause analysis. And especially if you have multiple tools, right? So that would be one of the things I would love to understand. Do you see your biggest advantage also to the agents that the vendors have, like Bits AI of Datadog or something, that you can really do that over multiple tools, right? If I have a Splunk here, a Datadog there, Dash Zero maybe, or other tools, Prometheus for metrics. So you can connect to all these data sets. And as far as I read your blogs, you're read only, right? So you only read the data, you don't store it. So you connect to all these tools, and then you help find the root cause in all these data sets, right? And combining them.
That's totally right. And that's why we've also found ourselves maybe early in our journey than we expected to be working with larger enterprises. Because when you start going mid-market and above, or significantly above, with some of our customers, they're using Splunk and Dynatrace and Elastic and Grafana and Datadog. I mean, they have every solution under the sun, right? And I think we've found that as the number of solutions you use grows, the pain of trying to root cause grows non-linearly with that, because hopping between these different solutions is really, really difficult, right? And
Yeah.
none of these original, like these vendors of the previous generation, are incentivized to give you insights into data stored in someone else's platform, right? Because all of the pricing comes from the amount of data that you've stored, processed yourself. We're marketing ourselves as the Switzerland, where we're not trying to store your data. We're simply trying to be the intelligence layer on top of it. And I think the observability industry in general is quite fragmented, right? There's always this war of attrition. I'll take a little bit, 10% of your data, and then some other salesperson says I'll get 10% of yours. And so there's this constant like back and forth. And so I think the fragmentation is high. Like even the biggest companies in the space have maybe 10% market share, something like that. That's, I think, why there's an opportunity for a company like ours to have a right to win, because you just never have all of your data stored in one place as you get to a certain size. And from our perspective, we're just building connectors to these things, and we pre-process the data. And by the time the agentic system looks at it, it becomes like a quote unquote traversal log or traversal metric. So it's pre-processed in a way where the agentic system doesn't care whether it came from Splunk or Datadog or Dash Zero or whatever it might be.
Yeah, and it makes sense. I don't know the exact number, but I once read, I think that the average number of monitoring observability tools of enterprise is 27. Right?
That doesn't surprise me. Yeah,
So there's definitely a market to
yeah.
kind of consolidate over that, because you also have the legacy tools for older tech and all these things, right? And then how do you do that, right? You connect, you read. Do you do that through an API or MCP server? What's your favorite way of getting to the data?
So at least so far, the MCP servers of these various companies are quite early right now, right? Because if you think about what an AI agent is, it's an orchestrator of tool calls, right? And it needs to have access to richer set of tools to be able to complete its task. And the types of tools that these different, Datadog or Splunk or whatever expose are still quite basic. And so you're not really able to use them in any sort of really interesting way. And so for us, we basically connect to the APIs. That's what we need, like the core APIs themselves. And in the background, we are converting all of that data into certain formats and then exposing tools on top of that that our agent can use. So we are building our own MCP server that our own agent calls versus the MCP servers of these different vendors. We talk to these vendors through the APIs.
Okay, so you basically harmonize the data through that MCP server so that your agent sees different logs in the same way
That's
from
right.
different
That's right.
vendors.
Yeah. And the tools themselves on top of them. So one is about harmonizing so that they look the same. And then the tools you give access to the agent are proprietary through traversal. Because there's an art to it. Because you make the tool, if you make too many tools, each of them too basic, then the agent can get confused because it doesn't know there's too many options. If you make the tools too big, then it's not flexible enough and it can't do what it needs to do. So there's this that's where like the art of software design comes in, of modern software design, which is like how do you make the tools just the right size so that they're both flexible yet the agent is stable.
Yeah, it's very interesting. So when we build our MCP server, and we are building an agent also on top of it, and I'm not very deep into the machine learning AI world, right? So, but the way I saw it is that the way a standard agent works is very similar to a human. That was kind of the way I saw it, right? So the tools that you provide to the agent and the way you provide the data is kind of the way you would provide that to a normal user in an observability tool, right? So if you have a troubleshooting tool that helps you digest, I don't know, millions of logs, then the agent can also use that very powerful, right?
So yes, I mean you have to get intuition from the way humans troubleshoot. But there are, I think, getting too married to the way humans do things can actually limit what these agents can do because they're very good at doing things that we can't do, right?
Yeah.
They have so much more context. They can look at so many more things in parallel. And so sometimes having the flexibility to not constrain yourself, so, oh, this is the way a human would troubleshoot, but trying to think from first principles, what is it that an agentic system can really do? That is also important at certain times. So there's like this kind of trade off between interpretability, because if you know exactly what like a human does, and getting an agent to replicate that, then you have a very interpretable mechanism. But if you try to exploit what these AI systems can do, then you might have a much more performance system, but you lose interpretability, which makes it harder to like improve the system. So there's again another trade off
Yeah,
that
yeah.
happens. Yeah.
And context is pretty important, right? For troubleshooting. And I read this interesting blog that you wrote recently about the three things you have to be careful about, right? I think it was index, time, and fields, right?
Hmm.
So, and the way I interpret it is that it's kind of very hard to narrow down the context in a way that you focus on that incident, because you can be too wide in a time range, use too many indices, use too many fields. So can you explain a little bit how you see that and how you are different from other tools, and how I benefit as a user from that?
Yeah, totally. So I think interestingly enough, obviously, if I think about a company, what they care about, the number one thing is accuracy, right? Accuracy is king. The second thing that is almost just as important is, can you respect the rate limits that a company puts on you, right? So if you have a large company, they will have an observability team that is in charge of making sure. Let's say they have a self-hosted observability. So the observability team will be in charge of making sure that their observability is stable, it's up, right? And so from their perspective, if you come in and say, I'm an AI agent system that is going to bang your observability system all the time, they're going to feel nervous. They're going to bring down their system, right? And so you have to essentially give a very strong contract of, this is the types of queries I will write. This is how often I will hit your system. So they can feel comfortable with letting you have API access to these systems, right? Because typically engineers only get UI access. No one really gets API access to these systems. So respecting the rate limits that these teams put on you is really important. And towards that, you cannot just write any query like, let me, pull me all data for the last 2 weeks. That's the crazy query. You'll be pulling in like petabytes of data. As a result, a lot of the work that we do, I'd say over the last 8-9 months, has been about how do you, if someone gives you a contract that this is the types of queries you can write, what is the right way that the agentic system query plans so that it's able to respect the limits but still get to the data it needs to get to. And then there's a second part of this, which is time, right? Because when you have an incident, you don't want an answer to come back in 2 hours. You want an answer to come back in 2 minutes. And if you write very, very small queries, you might respect the rate limits, but then the time it takes you to get to an answer and build up the context you need in real time is too long, right? So there's all of these different trade-offs you have to manage at the same time. And part of that is building the right offline cache of your data so that when an incident happens, you don't always just ping the system real time. And so it's all of these different trade-offs you need to think about to design a system that both respects rate limits, but it also gives you an answer in a short period of time when an incident occurs.
Yeah, that makes sense. And you mentioned it's all about accuracy, right? At the end of the day, right? How good is the answer they get for your problem? So the root cause analysis. I saw you have a categorization, right? Like bullseye RCA and directional RCA. Can you explain where you think you are today with Traversal, and how would you as a user evaluate the accuracy of a system?
We've learned a few things actually with working with these large customers, or actually all customers, is that the way you build loyalty with with your users is getting a bullseye often, right? And early in a pilot, in a partnership. If you get to a few bullseyes early, you will have a lot of loyalty from a company and a set of users. If you don't get there, then they'll forget about you very quickly. And so to get a bullseye quickly, you should, and to get a very high accuracy, you need to basically constrain the search space. And so essentially you need to work with the customer to figure out, with these search parameters, if I tell you XYZ before the search begins, you'll get to a bullseye very quickly. And so what we found is that if we spend a bit of time with a customer, say a few weeks, then we can get to the bullseye really quickly because we can constrain the search space in just the right way. And so there, I'd say accuracy is, I'd say greater than 90% if the search space is constrained enough. And that is basically work on both sides to get there. It's still very valuable, and it's actually the most valuable thing you do. And then you can, if people ask very broad questions like, what is wrong with my system? Right? That is a very, very broad question that is ill-posed almost. Any engineer that first comes onto a system like Traversal, the first question they ask is, can you tell me something that's wrong with my system right now? Right? And you want to service those kinds of questions too, because that's how you don't want people to first use your system only when an incident happens. You want them to be able to gain familiarity with your system during a time of low stress, right? And that's where they want to explore and understand how about their system and get insights about their system when nothing is wrong, or something is wrong but not burning. And so in those kinds of systems, I'd say again we have high accuracy, but then it's not the bullseye. It's one of the things where you get to an answer that's directionally right, but not something that's insanely specific. And what we've spent a lot of time over the last few months now doing is building a much more multi-turn interactive user experience. And so then one thing we've been measuring now for accuracy is, do you get a bullseye within one answer, or do you get a bullseye within 2 interactions or 3 interactions or 4 interactions with the user? And so the point I'm making is that getting to a bullseye is key. And the question then is like, well, how many turns does it take to get to an answer? And so the two things that measure is how specific is the first question they ask, and then how many turns does it take between them and you to get to the answer. And we measure both of those things pretty closely and carefully.
Do you give the user an indicator how good the answer is that you are providing?
Yeah. So for every answer we give a confidence level, and we
Okay.
explain the confidence level. And typically the way it works is, for an answer to be highly confident, you need to have many smoking guns that point to the same root cause. So your metrics, your traces, many different logs, your PRs, if they're all pointing to the same thing, there's very high confidence. If it can only find one thing that points to that root cause, then it'll say it's medium or low confidence. And actually, an interesting thing that's come out of that is that these LLMs actually are then tell you or give you recommendations to say that, hey, if I actually had these 2 more smoking guns, then my confidence level would be higher. And sometimes users use that to figure out a better way to instrument their data, right? They use the confidence as a way of saying, oh, actually, okay, let me instrument that so that in the future, the AI will be more confident. And so that's becoming, the confidence level in some ways is actually becoming a recommendation system of how to instrument your system better, which has been an interesting unintended consequence of what we've been doing.
Yeah, I read an interesting article of Google. They were explaining that one of the issues is that a lot of tools, and I can relate to that from my Instana times, we always try to give you the one root cause. And they explain in the way of search, right? Think about, you would search for something and they would only give you one answer. And not like today, 10 or 15, right? And yes, you can put the one that's the most relevant on one, but then if it's not correct, you can still go to 2 or 3 and find your answer there, right? Where when you give only one, there's a high frustration level for the user if sometimes that's the wrong answer, right? So I could really relate to that sometimes you have to give the user a confidence level, but maybe also different choices, right? Say, hey, we are most confident that this is the root cause, but it could also be this or this, right? Are you doing those things too? Do you give only one or multiple things that you have found?
Yeah. So at least right now, based on just collecting data from user sessions, we actually give between 0, not just 1. We give between 0 to 4.
Oh, okay.
And so there are a number of times where we'll say no root cause found. Because one thing I think that users hate is if you lead them down the wrong direction.
Yeah.
right? And so I think actually they appreciate it when you say no root cause found, because then they know to move on with their lives and do what they were doing originally. And we have found that if you go beyond 4, then it looks very noisy. It's like you don't really know what you're saying. If you give too many options, and people are like, do you really know what you're talking about? And so somewhere between 0 to 4 is the sweet spot, is what we found. The exact number is actually dynamic. So the LLM somehow decides based on the confidence scores how many it should show, but not more than 4. And that's part of the multi-turn thing as well, which is that you can then say, hey, actually, this is the one that looks promising. Let's spend time on that. And that's one of the key things we measure, is how many turns does a user have with the Traversal AI system.
Yeah, makes total sense. And I also saw in this video on your website that you have a nice dependency service map somehow, right? Explaining to the user how things are connected, and probably also to show where all these smoking guns point to, right? That's
That's right.
that's so how important is that map, and how do you generate that? I was kind of, oh, this is not easy, right? If you don't have access to the underlying, I would say, system, and you only have the data like logs and things, it's not easy to build that map.
No, that's it. That's a big part of the work we've done, is how do you build that dependency graph, and that's where I'd say both a lot of our research comes in, and also these LLMs are very good at it, right? Because they can literally read the content of the log message fields and learn the causal dependency from the words themselves, right? And so if you look at both the time series of the data and you look at the semantic content of the messages, you can start building these dependency graphs, and that's what we do. And it doesn't need to be perfect, and it's also dynamic and changing all the time, right? Both spatially and temporally. That's been a huge part of like the technology we've built, is building that dynamic graph over time, and that's both a function of good statistics and good LLMs and get you there.
And how do you see open telemetry in that regards, right? Because I mean, what we have seen is that if you have open telemetry data, the LLMs are really good in understanding it because there's so much documentation around it, right? And so they understand fields or tags pretty well, and then they can also map it.
Yeah, I mean, I think that's part of our, as we think about technical qualification. If someone is using Hotel, that's a great thing. That makes them a very desirable customer, because we feel we can add value quickly. And a big part of it is indeed that LLMs have been trained through world knowledge to be good at understanding data that's formatted in that way. And so I think it's a great thing for the community, obviously, Hotel, but it's also a great thing for AI. It turns out. So yeah, I think I'm a believer. So the more people that use Hotel, the better.
And if it's not Hotel, so sometimes you have to do the mapping, or how do you do that? How do you train the model to understand things that are not publicly available standards?
There's a lot of company documentation then you have to use. So a big part of what we do is we slurp up the internal documentation, whether it's Confluence or Notion or your previous Slack messages. And so those all are being used to learn these interesting dependencies. Obviously, tracing helps. A lot of times people have service catalogs. And so you basically try to use as many different inputs as you can, and to build a dependency graph that is as consistent from these different inputs that you can find. Um, so yeah, I'd say there's no one answer, and every company, as you know from observability, is built differently. You need to have an opinion as to what you need to get there, and then use whichever way you can to get to that point. So I wouldn't say there's like one magical bullet, when we're still learning all the ways you can get there. But at least a few ways that have turned out to be useful. Obviously, hotel tracing, service catalogs all help, and then obviously statistics and LLMs can then append and in a way that you just couldn't do a year ago. So that's helped also make it a lot easier.
Yeah. I was talking to a founder here, and I found that very interesting. They were working on something to use actually video conferences as a source. And the idea was, and I could relate to that. So a lot of times you have things like, okay, a market team discusses that they put an ad on Super Bowl, and then your application crashes because you have too many requests, right? And so the idea of him was, if I can get those recordings and the text, I can maybe correlate those things, or two SREs talking about a database migration tonight, and then something breaks. So you could relate to that conversation and say, hey, maybe that's the root cause. Those two guys talked about a database migration. Now we have a database problem. Exactly that's time frame. So I found that pretty interesting. So that you could open up the the data sources to very different data sources than traditional observability data.
Yeah, so I mean, I think if I think about LLMs in some ways, right? Like the way with databases that you can store and query structured data, and in some ways the LLMs, if you view it the lens of databases, now you can store and query and index unstructured data, and from that simple leap, it has incredible implications, right? And in some ways, an LLM is the world's worst database. I think someone said that once, and I found that very funny. Uh, though to your point, I think some of these ideas of, oh, let me look at every previous Zoom call transcript or Slack conversation and connect that with the root cause. It sounds good, but I found actually that there's a lot more signal in your traditional observability than you know. It's just
Mm.
that no one is monitoring it. There's so much. If you look at the amount of data that's actually looked at, right, it's probably 5, 10, 20%.
Yeah,
Right? Most
less
of
I
the
would
data, no
say.
one ever
Yeah,
looks at it, right? And actually,
yeah.
there is a lot of signal in that data. You don't have engineers who have the bandwidth to look at it. So we've actually had a different opinion, which is that the observability data is a lot richer than you think. You just need to have an agentic system that's able to comb through it effectively. And to do that, then you need to think about like rate limits and infrastructure constraints because it's petabytes of data. So at least that's been the opinion we have taken. Obviously, these other sources of data are important, but first you should exhaust the traditional stores because they're very powerful.
That's an interesting point. And would you say that this could also change the way? I mean, as observability vendors, we think more and more about pipelines, right? And tools like Cribble have done a great job of building those where you try to reduce the amount of data you are storing, right? But to your point, it could be interesting at some point to not do that. I mean, not thinking about price or something, but to store a lot of data because now you have this agent which can look at all the data and maybe find signaling inside of the data that a normal engineer never would have found, right?
That's right. I think, and it's interesting. I think there's both can be true in some ways. I think one is that the logs that we create now, they're meant to be human readable, right? Like a lot of times. But you could consider a world in which it is no longer meant to be a human squinting at a terminal and seeing what that log is saying, right? But it's meant to be parsed or grokked by an agentic system, and so you might make the log a lot more voluminous than currently. You just have a lot more data in it than you currently have, right? So a single log might be just much more descriptive about the system than you have. It might use human readability, but it makes it more agent parsable and rich. And at the same time, you might say that, hey, actually, there's a lot of redundant data between different kinds of logs, and that can be reduced. And so I think both things might happen. I think we might find, as these agentic systems start becoming the systems that are querying your data, you might figure out which data streams are actually effective and which ones are not. You might find that you actually need everything. You find that actually only 20% is effective, 50%, I don't know. And so that might be true. And I think at the same time, the way we structure logs, the way we structure metrics will change and probably become much more long. And it's interesting to see how it plays out. I think the way telemetry looks like in the next few years is going to change in really interesting ways that I'm excited to see and be part of.
Yeah, it makes total sense. Yeah,
Yeah.
absolutely. And how do you see this space evolving, especially in terms of automation? I think one of the things, if you look at those systems, what you would like is not only get the root cause, but you also want the agent to do the right things
Yeah.
to
Fix it.
resolve the
Yeah.
problem, right? Restart
Right.
a container or roll back the code change that caused it, right? So, do you see that happening, or is there still not the confidence of the users to do that, or how do you see that evolving over time?
I'd say it's possible, and we are doing that actually with some very complex enterprises. We are actually doing things like restarting pods and scaling pieces of the infrastructure, rolling back commits, changing code. So it's already happening, and I think it's if I had to predict 2 years from now, it'll be happening in a much more rich way. I think we'll have end to end outcomes from an incident to a full fix. Certainly, I think when you begin with a company, no one's going to give you right access and let you do whatever you want to do. And so you have to earn the right to that by showing high accuracy on the root causing part of the journey. And I think if you can do that effectively over time, then I think the next journey, there's at least the journey we've been on, is that then and the companies will give you they'll give you basically whitelisted set of commands that you can run. So they won't just say do whatever you want. They'll say these are 50 commands that you can run, Now, given these 50 commands and given the root cause you have, can you go, come up with a sequence of commands that will go fix the issue in some sort of constrained, heavily guardrailed way? And that team are getting comfortable with is what we've found, especially if the command is something that is not going to bring down your system. It might be expensive um, to do that command, like from a resources point of view, but it's not bad for your system. I think those are the types of things that we're already seeing. Um, yeah, how it plays out over time, I think people will get more and more comfortable with it over time.
Yeah, and is it fully automated, or do a user has to acknowledge it? That I think that's also an intermediate step that you say,
Yeah,
hey, I suggest doing this
yeah,
because of that, and press a button to do it, right?
yeah. So that's very much the case right now. You you
Yeah.
you have to press a button. We don't just go do it. I think that's
Yeah.
probably best for everyone involved. Yeah, yeah.
No, no, absolutely. And what kind of workflow systems do you see doing that? I mean, is that just a simple command, or will there be workflows that the agent decides, or will you model workflows? That's also something I'm thinking about. Is like, will there be kind of new workflow systems like the N8Ns for observability or SREs?
Totally. I think likely that will happen. That's what we're doing. In some ways, we're manually constructing workflows for different kinds of remediations. Or actually, a lot of companies have these scripts. They have a lot of automation scripts, like different kinds of runbooks or other systems. And the problem is they have thousands of them, and they don't know which one to run. But again, an AI system can semantically understand what each of these different workflows do, and then route you to the right one, and they just become a router in some sense. And so at least right now we're in the world where it's all manually constructed at some point versus the agentic system fully constructing that workflow. There's been one company with which we are doing that. So it's called Cloudways, which is like a web hosting company where it's guardrail, but the AI system is actually constructing the workflow in a very constrained way right now, mind you, but it is constructing the workflow. Every other company, it's a pre-existing workflow that we're just routing to. And how it evolves over time, it'll be interesting to see.
I have one personal question that I'm really interested in, and I'm trying to think about, and it is how this whole AI world and agentic AI will change the observability world, right? As an observability vendor, because I think what I can see is that tools like your tool will essentially use observability tools through an API, and then we kind of lose the control about the user, right? Because why would a user log into an observability tool if you or your agent does the work for you? So we will at the end only be a database, right? Which from a I would say value perspective is not that valuable anymore, right? Do you see that happening, or do you see that more working together? You provide something, and then the user will still log into observability. So how disruptive are you seeing that topic, and how disruptive will that become for this whole space?
I mean, I think it will disrupt. So I think it's an inevitability that it happens, right? That there will be a fundamental rethink of how users interact with telemetry data. I don't
Yeah.
think in 5 years you log on to a system and you look at a bunch of dashboards, and I think it'll be much more a system is doing the workflow. Now, who does it? It's unclear whether it's a company like us, which is trying to just be a purely agentic company, whether it's an observability company that grows into this. I don't know. I think,
Yeah.
but what I do know is that the thing will change. How the field plays out, it's interesting. That remains to be seen.
Could also be a tool like Cursor, right? Winning the game. We are integrating into Cursor through an MCP, and sometimes it's really powerful to see how through your IDE you ask questions, and then you get direct feedback translated into code changes, right? So I could also see that happening, right? That those IDEs get much more powerful in terms
Absolutely.
of what use case they do, right?
Yeah, there are a lot of engineers developers who use tools like Datadog every day for something or the other, right? To get a sense of system health, right? So I think for like simple queries, like, pull me this piece of log or like pull me this dashboard. So for these simple kinds of queries, I think the IDEs can do a good job and already are doing a good job. I'd say for like complex troubleshooting of incidents, you have to kind of live and die by that. That has to be
Mm.
what the company is based out of, just on the amount of infrastructure work that is required to make it happen. I mean, who knows? But I think it'll be very hard for an IDE player to do that. I think they can do simple retrieval tasks, but not like complex troubleshooting workflows. And you can actually argue the other way, which is where I think some of the SRE tools which are on the production side might also start eating away onto the IDE side, right? So I think it's a competitive space. It's a big prize. So I'd say though there's competition from every which way, but it's big prize. So
Yeah, absolutely. And exciting times, right? It's really good to
yeah,
be in that space during those times where things change, and that always opens up possibilities for vendors like us, right? Who are new in this space and have to fight the big
yeah.
guys who are there with billions of dollars, right, of revenue already. Yeah.
Yeah, I think it's been a privilege working on this problem. I think we say we've fallen in love with the problem. Like it's a really good fun problem to be working on. And I think if I think about the team here, like everyone who's here, like if I think about what combines them, engineers love this problem and they want to solve the problem. So it's been really fun, honestly. Like you enjoy going to work every day.
Oh, that's great. Anish, it was a pleasure talking to you. I will follow your journey very closely. It's fun seeing that space evolving and seeing how much money goes into it, right? And I think it is absolutely a problem that I think the whole space tried to solve for 20 years. It never got really close. So I think this time I can see it happening. Yeah.
Yeah, I hope so too. Thank you for having me. It was a pleasure, Mirko.
Thanks for listening. I'm always sharing new insights and insider knowledge about observability on LinkedIn. You can follow me there for more. The podcast is produced by Zero. We make observability easy for every developer.